Hello everyone, Namanjot Singh this side from NetClass again. In this video, we will discuss about OSI reference model, about how OSI reference model, how we got this OSI reference model, what was the history, what is the use of it. All the things we discuss about networking is somehow related to OSI reference model. You do the troubleshooting, you do the standardability, sustainability of any system, somehow it is interlinked to OSI reference model. It is a very important concept again in the networking. So let's discuss about it. So let's see what OSI reference model is. And before knowing what OSI reference model is, let's answer the question why we need it. We need OSI reference model. The simple answer would be for the standard. Back in, if we talk about history, let's say IBM created some computers and digital technology created some computers. Both of these computers were not able to interconnect with each other and not communicate with each other. Why so? Because there was no language which was a common medium between them. So this was the reason they were not able to communicate with each other. So what happens is ISO introduced OSI model in 1984 so that they can communicate with each other. This was the reason why OSI reference model was created, and it is a layered approach. OSI reference model consists of 7 layers. Remembering these 7 layers is very necessary, and that too in sequence, because physical layer is called layer 1 and we don't call application layer 1. There is a dedicated name assigned to layer 1, that is physical layer, data and all, as we go upward. So it is a layered approach, this OSI reference model. If we talk about how we can remember all these layers, you can follow a simple line, that is, please do not throw the sausage pizza away. P stands for physical, D stands for data link, D, N not stands for network, T in throw stands for transport layer, S in sausage stands for session, P in pizza stands for presentation, and away in A in away stands for application. So this is how you can remember all these things. So let's see. The layer 1 is physical layer, layer 2 is data link layer, layer 3 is network layer, layer 4 is transport layer, layer 5 is session layer, layer 6 is presentation layer, and layer 7 is application layer. So what was the advantages of OSI reference model? The simple advantage of it is interoperability. So this simple term means is when two different vendors can communicate with each other, there is a standard, so they follow interoperability. This is the reason. And other advantages, simplification. Why we call simplification? Because somehow every component or every technology in the networking should fit into one of these layers or either two of these layers. It is called OSI reference model, not OSI model, because OSI reference models, it is a reference model. It is not a hard and fast rule that everything should fit into one of these layers. But yes, they should fit somehow in between one of two layers, and the other is training, for the training purpose, and troubleshooting. For training and troubleshooting, why so? Because when we troubleshoot, we first see at specific layer 1, and as we move upward, we see the different layer. Is there any error or is there any problem in the given layer of it? So let's take the first 3 layers first: the application, presentation, and the session layer. Sausage, pizza, away, session, presentation, and application layer. Layer 7 is the application layer, layer 6 is the presentation, and layer 5 is the session layer. So let's discuss about the application layer first. So application, when we say application, This is not the application which we use like Microsoft Word, presentation, PowerPoint. This is not that. So application layer is point of contact for network aware applications. What this means is, if there is an application that know how to use a network, then we will say there is a need of application layer. If there is the application, if there is the application and that application don't need to take the advantage of network, so application layer doesn't work there. So first is point of contact for the network aware application. Then it is the interface between you and the system. This is the interface between you and the system you see, and there are many advantages of it, and there are some protocols which we will discuss in future but fit into this. So network aware, okay. And moving further, we come to presentation layer. As the name suggests, presentation layer means to present. To present means how data is presented to do. Like you see a photo in JPEG format, you would say there is a certain format, there is a certain presentation which we can see. So presentation layer is all about this presentation which you see, like about how you see the things, ASCII code and all. This is all about presentation layer, and encryption also happens in presentation layer. If you see encryption, this also happens at presentation layer, encryption services. So let's come to the other layer, that is session layer. The main job of session layer is to make and tear down the connection. Okay, to make and tear down connection. And reporting problem. And maintain different sessions with the help of transport layer. So what happens is, like in session layer is helpful in creating the connection between the two nodes. For example, you are having a node 1 and node 2. You are creating one connection. Let's say you are accessing the web page of this server, and now after accessing the web page, you are also using the FTP service of this server. So in this way, it also helps in creating multiple connections of a system with another system. So we have discussed about these three layers: layer 7, layer 6 and layer 5, session, presentation and application. These are important layer, but from the networking point of view, these are not very important as compared to layer 1, 2, 3, 4, because as a network engineer or in the field of networking, we are more concerned about the issues related with the lower 4 layers: physical layer, data link layer, network layer and the transport layer, which we will be discussing in this video further. So important layer, layer number 4 is transport layer. So let's discuss about the transport layer now. Before discussing about transport layer, let's discuss about an important concept, that is PDU. PDU is, let's discuss here. So what is PDU? PDU is protocol data unit. So what this means is, as the name suggests, it is derived from protocol. So like now if we are moving to below layers like layer transport, then network, then data link, then physical layer, a specific header would be added to data and the before passing it to the next layer. For example, if transport layer is passing the data to the network layer, it will add it on header which is known as PDU, and this header would have different name depending upon different layers. For example, if there is a data coming from the above layer and the above layer is session layer, right? If data is coming from application to presentation, then presentation to session, then session to transport layer. Now at transport layer, a PDU, that is segment, would be added to the data header. So this is the data, and now a segment would be added to it at the transport layer. So this is the first job of the transport layer. Now the main job of transport layer is to make a connection, that connection bit being reliable or unreliable. So transport layer creates a reliable or unreliable kind of data. When we talk about this, when we talk about data being reliable or unreliable, we are not concerned about whether it is a best way or not. The reliable and the unreliable concept is coming from whether the other person is ready or not. For example, I throw a ball at you, and if you are ready to catch that ball, it would be considered as reliable communication. And if I throw 10 balls at you, but you are not ready and you can hold only one ball, then I would say unreliable communication. So if we are talking about data transfer, reliable communication is necessary. In voice transfer also, if we are talking about video transfers, unreliable is a most efficient way to transfer the data, because even if one pixel is not there, it would not make much impact at the other end. So this is the reason, reliable or unreliable communication. In reliable communication, we call it as a TCP/IP communication, and unreliable is UDP. The full form of TC is Transport Control Protocol, and UDP is Usergram Data Protocol. So in TCP, what makes it reliable are few concepts. The first concept which make it reliable is flow control. What this flow control means is controlling the flow. For example, giving it a window size. What this means is, let's discuss about reliable in transport. We are discussing about communication. In communication, we are discussing about reliable communication. Reliable communication, we are discussing about flow control. So how this flow control work is, we are giving it a window size. For example, there is a PC1 and there is a PC2. PC1 is sending data to PC2, and there is a window size of 2 packets. So only 2 packets would go through it. After that, we will receive acknowledgement. Okay, you can send more than 4 packets will go through it. And if 4th package is dropped, then there will not acknowledgement, then computer will bounce back to sending 2 packets only. So in this way, we are setting a window size so that our communication would be reliable. And in reliable communication, flow control, we also have, in flow control, we have windowing, and we also have ready or not ready signal. We have ready or not ready signal. So in ready or not ready signal, what happens is, for example, you are sending data. If you are getting a ready signal, then you would send the data. If you are not sending a ready signal, then there is no transfer of the data. Windowing is better than ready not ready signal. Reason being, if you are waiting for ready not ready signal, you are wasting a lot of time. So this is the reason windowing is better. So flow control is another importance for transport layer gives to us. The other is multiplexing. Multiplexing means making multiple connections. How this multiple connection is meant is by port number. So port number is like, we would say, you can say this computer is making connection with this server, and it is using port number 80, that is HTTP. It is using HTTP. So it will be having a source port number as well, and a destination port number. Destination port number is designated, let's say 80 to the HTTP, but we can change the source port number. So changing the source port number, if we say, we can the destination port number would be same, and if we change the source port number, we can create multiple sessions. So talking about the port number, in port number we have 0 to 1024 reserved port number, and 65536 something to we can go up to this port number. So 0 to 1024 reserved means these are the reserved services. Like for example, port number 80 is for the HTTP, and so on so forth with other port for other port numbers. So in TCP, reliable communication, we say it is a three-way handshake. So what three-way handshake is? For example, you are sending a data, you're here and your friend is here. You are sending, before sending a data, you are sending a sync signal. Sync signal is received by it, and in the reply of this, someone is sending you sync plus acknowledgement, and in reply of this you are sending acknowledgement. So this is three-way handshake. After this you can start sending data. So this is known as reliable kind of sending data. So now come to the other layer, that is network layer. Coming from the transport layer, now data is having a header of segment. Now at network layer, another header is added, and due to this header we say this is a packet. This creates a packet. What is the importance of network layer? It is useful for the logical addressing. What logical addressing is? IP addresses. So if you see the example of any big network, every node have a IP, and when we are talking about some complex networks with multiple routers and multiple switches, we should know the best path to send our message, because we do not want to create a loop. For example, these are 4 routers and connected like this way to this. We don't want the data to go like this and then to this. We want this to be like this. So the best way. So network layer also helps in following the best path for data transfer. Okay, and then creating the routing table and all that we will discuss about in future. So network layer is all about IP addresses, the logical topology, and following the best path for the network, for the packet to go. And now we have the PDU, protocol data unit, that we call a packet. Now when data is transmitted to the next layer, the second layer of OSI reference model, that is the data link layer. So now we have data, segment, packet. Now at data link layer, the header is added as frame. This frame is added. So data link layer is like the network layer was all about the IP addresses, the logical addressing of the network. The data link layer is all about the MAC addresses, the physical addresses of the network. So what is MAC is? Media Access Control. As the name suggests, it is a designated 48-bit hexadecimal number given to the chip, that is the NIC, which we will discuss in future, and we have discussed it in a previous video also about the NIC. So that NIC is having a MAC address. So like our computer is also having a MAC address, so data link helps with this MAC address, MAC addressing, and it also helps in error checking during cyclic redundancy check and many other checks. Like error checking is also done as data link layer. So this MAC address we will discuss in future, but in a short, it is a 48-bit hexadecimal code given to network interface card. If you see my PC, if I go to command prompt and if I type config ipconfig, you can see my MAC address here with this command, ipconfig all. So this gives the detail of MAC address, like you can see in this output here. This is the physical address, like MAC address of the local area connection of the connector. Okay, like this. So it is a 48 bit. We will discuss it in future. So like this way. So MAC address is all about this. So now moving further about the physical layer. Now when data is transmitted to the other layer, that layer is known as physical layer. And now bits, physical layer is all about bits and bytes, zeros and ones, which we have discussed in first video, bits and bytes, zeros and ones, and we will discuss in future as well. So in this layer, data is it comes cables, all the hardware, all the physical things kept in the physical layer. So when from the troubleshooting point of view, we will first see what physical layer, about the physical layer, like there is no issue with the cable and all, then about the data link layer, then with the network, transport, session, presentation, application layer. So as we move down, sending data from this to the physical layer, because eventually wire are sending the data as physical layer, 0 and 1s, right? So this process is known as encapsulation. And going upwards, when we defragment the data, like from the data we first take zeros and ones, bits, then we take the frame out, then we take the packet out, then we take the segment out. This process is known as de-encapsulation. Because as we are creating this data segment, packet, frame, we are adding the header, we need to strip down it also to make it appear to a laptop screen. So in this way, the networking work, the first things comes to the application, then application give it to the presentation layer. It is converted to a presentable format, then it is forwarded to session layer. Session layer helps in creating the connection between the two nodes and maintaining the connection. Let's say now the connection is maintained between two. Now it comes to the transport layer. Session layer with the help of transport layer has created a network. Now this connection would be reliable or unreliable depending on our decisions, what our preference is. Segment is added. Now data is forwarded to the network layer where segment and where packet is added. Now data is given to the data link layer where error check-ins happen and all physical MAC addressing happens. At this layer, frame is added, and at this bits and bytes are added and forwarded over to the cable. Now once the cable receives the data, it converts the zeros and ones. Now we strip down the frame, and network layer we strip down the packet header. At transport layer we strip down the segment, and after moving we have a data. Now this session layer is already maintaining the communication with the device A. At presentation layer, it is converted to presentable format, let's say JPEG. And now at application layer, some application aware application is giving the output at a device screen. So this is all about OSI reference model discussing in short. There is also a fun way. I have made a video on it. You can check it in the I button. I have mentioned in the group description as well, this channel description, this video description. You can have a look at that also, the fun way to learn about OSI reference model. That would give you a better edge on it. And don't forget to subscribe our channel. NetClass is working so hard to bring the best content forward for the people to help, not just someone who is preparing for the certification or for the studies, for anyone who is interested in the field of networking. So thank you guys so much for your time, and stay with us for future.